Hello everyone. In this video, we'll be solving problem named proxem. In this question, what we have to do is we have to start from the starting index and go to the last index and count the minimum number of energy required to go from first index to the last index. The catch here is that we can jump from one index to its another from I to I plus 1, and another step is we can go from I to I plus 2. So we have to, and the energy will be from going from I to I plus 1 will be is the subtraction of the value in the I plus 1 and the ith index. So this will be the energy. The subtraction of these two values will be the energy required to go from here to here. So we need to find the minimum energy to go from I to I from first index to last index. So what we can do here is we can try all possible ways. We can here try all possible ways and check what is the minimum coming. And after that, we know that this question has overlapping subproblem. So you can memorize it and return the answer. And the recursive will give you the answer in exponential time complexity, and the memoized version will give you the answer in big of and big of n time complexity. Let's see how we can code it. So we will just create a function int minimum energy int index. We will require the int vector of height by dsts, and what we will do, we will just call the function from here into energy, and we will traverse the array from the last to the first. You can also go from first to last, but we are traversing from last to first, and we will just pass the heights array. Let me write the min energy function. If our index is equal to 0, that means I am in the place in the last position where I have to, because I am traversing the array from the last, so I have to go to first. That means I am in a position where I have to be, so the energy required will be 0. If you are going from one to the first to the last step, then you can write if I index is equal to n minus 1 or n, depending on which index you are using for the array. And in the first step is we can go is index minus 1. We can go in take first step and just pass the heights array. And the second step will be we will initialize it with int max. Why? Because we can be at index 1. If we are at index 1 and if we do index minus 2, it will go to the negative index, which is not possible. So we will just, while doing the index I minus 2, we will just put here that if index is greater than 1, only you do this step. So we will just go here and we will just energy minus energy and index minus 2 and height, height. We'll just pass the height. And when you jump from the current index to its next index, the energy loss will be absolute of heights of index minus heights of index minus 2, sorry, index minus 1. And over here it will be heights of height of index minus heights of index minus 2. So now we have calculated both the from the first step and from the second step, and we just return it the minimum of both. Let me just run it. So as you can see, this solution is giving us time limit exists for some test cases. So we can memorize it and submit it again. So let me create a vector of tp of size n and initialize it with -1, and we'll just pass this array to the function and go. Let me write here vector of int ampersand dp. If our current index is, because this problem has a lot of overlapping subproblems, if our index dp of index is correctly calculated, we don't need to calculate it further, so we'll just return dp of index, and while returning we will just store the calculated value in our array and just run it. Okay, sorry, I forgot to pass dp here. Let me just submit it. So as you can see, it got accepted. The time complexity of this solution is big O of n, and the space complexity is big O of n. Thank you for watching.